All right, what is Kadena? We are a smart contract ecosystem. And what does that mean? What is a smart contract ecosystem? So we have a private blockchain and a public blockchain that work together. You can use one or the either or both. And they're both designed to have smart contracts sit on top of them and run. And so unlike some of these other smart contract platforms that may have been designed as a thought experiment, or maybe some guy was like, maybe I can write a virtual machine in a weekend, and then people accidentally adopted it and now it's trading billions of dollars of currency. We were designed from the ground up to be designed for users and people to actually be able to know that what they intend to happen on the blockchain is what they're going to get. Okay. So before, we all know what a blockchain is, but in case you go to business school here and you wandered in and you don't know what a blockchain is, for the purposes of this discussion, it's a list of records linked using cryptography. A block is a cryptographic hash of the previous block and some timestamp and some more stuff. So basically it's an append-only ledger. It's a type 1, type 2 enforced database system for those of you with data engineering backgrounds. So it is resistant to modification of data. You can only add new things and you can upgrade things if the system lets you do it, but you can't ever go back and change something. And this is why blockchains are so interesting. So in private blockchains, only the people that are allowed to access the system can come in and make modifications and see what's going on. In a public blockchain, and this is what was truly novel about Nakamoto consensus in the first place, is that you can have this idea of a ledger that people can't come in and screw around with and totally mess up, but that everyone can contribute to. So popularizing this idea of smart contracts, you can have code that is replicated on all of the nodes of a blockchain, which then allows people the potential to have distributed applications, which when you think about it, instead of having to pay Amazon to spin up an EC2, which is really just a server in Virginia, in order to run your app, you can, by paying whatever the gas fee is on Ethereum these days, have your code run by hundreds, if not thousands of people all around the world individually. And like my friend Felix in Berlin, who has a mining rig in his closet, will run your code. And so nobody can take down Felix's rig and Amazon EC2 in Virginia and all the other thousands of people that are running your thing, which is why distributed applications are potentially so cool. Okay. So what is the Kadena ecosystem? I use the word ecosystem. So we have a smart contract language that I'm going to just come out and say is the safest, the simplest, the best smart contract language. And it's fully open source. Anybody can go and use it. Right now we're on version 2.8, version 3 coming soon. We have, I'm going to go in and talk about Pact and why I think it is the best. And we have scalable BFT, which is a fully BFT and not like just a database with fancy permissions on top of it. And it actually scales. And I'm going to go in and talk about some other private blockchain companies and what they're working on and how I think we're different. And then we also have a proof of work public blockchain. And all of these pieces fit together so that if you came along and you were like, I really want to make, let's take Tarun talked about tokenized real estate. I really want to make a tokenized real estate application where I can have data about who owns what pieces of properties, but I don't want that exposed to the public. I want that on a private blockchain, but I want to be able to sell those tokens in public on a public network, and I want it all connected, all in the same system. That's what we do. This thing, okay. So we're a base protocol, sort of like all of these other smart contract-based protocols, like Ethereum, like some of these others. I'm actually being a little disingenuous with this graphic because I have both private blockchains and public blockchains up here at the same time. But so on the left, you've got other things that are proof of work. And say what you will about proof of stake, it has the potential to be really cool, but nobody has proven yet that it works. As opposed to Bitcoin, which has had 10 years of people trying to kick it over, and it's still standing. So we believe that proof of work is, if you can do it more efficiently, proof of work is still going to be the way. So other projects that are designed for scale, We've got Hashgraph is up there, Dfinity is up there, but they're not proof of work, and they don't have smart contract systems unless something has changed since the last time I went around and looked at what they're doing. Other smart contract platforms like Hyperledger, not necessarily scalable to the same degree that some of these other projects are. So we've got all of these things that I think are important. So I'm going to go in and talk about all of these things: Pact, scalable BFT, Chainweb. I don't have a lot of time, so I'm going to move a little quickly, but then we can have questions afterwards. So Kadena ecosystem: reliable code that checks itself, stable, secure networks that resist censorship and attacks, and applications that reliably scale. So first, Pact. Why I think it is the best smart contract language. So first, what is a smart contract? This is the idea that you want your app to be run by Felix in his GPU cluster in Berlin, as well as thousands of other people. So execute the terms of a contract. I want to transfer some value from me to some other person. And this chunk of code is included in a blockchain transaction, and it's rerun by every validating node upon receipt of the block. And everybody on the blockchain can see what you're doing. Smart contracts allows you to distribute code and in a censorless way on a public blockchain. On a private blockchain, it's a way for you to put transactions out there that you can broadcast to all the members of the network, and no one can say that you didn't say what you actually said. So, smart contracts, if we can figure out how to really do them right, have the potential to be really cool. Like, if you've ever tried to rent your apartment to somebody or like buy something on Craigslist and you're like, I want this thing, but I don't know if it's going to work, and I don't want to send you the money until I know whether the thing works. Like all of these things that actually happen in real life, escrow transactions without somebody in the middle where you both have to sign off on the thing. Tokenized real estate assets that settle quickly with a little overhead. There are a bunch of illiquid assets out there that people want to buy, but you can't trade them because there really aren't markets for them, or they can only trade during the day, but they can't trade at night, and there's an arbitrage opportunity. There's a whole world of things that we could do out there if we knew that smart contracts weren't going to suck. Because right now, smart contracts suck. They just do. You've got I'm going to go in about really why they suck, but people can't expect that the thing that they intend to happen is going to actually happen when they put smart contracts on a blockchain right now. So, for example, I'm just going to pick on Solidity because it's easy to pick on Solidity because everybody hates Solidity right now. It has a bunch of flaws, and some of it aren't its fault, some of it's the EVM's fault, but let's just roll it into a whole ball and say that it's the EVM plus Solidity. There's a whole bunch of bugs in the Ethereum virtual machine. And right now, if you have a bug that's out there, everybody can see it, you can't change it, and it takes a massive consensus of all of these people to say, oh, we're going to hard fork the network to fix this thing that is broken that everybody can see is broken. It's a huge mess. And right now, if somebody has a smart contract and they compile it and they stick it onto the chain, you don't know what that blob of code is. It's impossible to check. And then you have, anyway, let's just start talking about hacks. DAO hack, parity wallet hack. Both of these things are well-recognized problems. This is why people can't trust smart contracts right now. It's, the DAO hack was a recursion bug where somebody could go in and they could hit the wallet and they could ask for money, and they could come back and they could keep hitting it for more money before anybody could go in and actually reconcile the account. And then parity wallet hack, you had, because gas is expensive on Ethereum and nobody wanted all of the code to actually be in the contract, you had a call to another smart contract, except that somebody deleted that smart contract, and now nobody can get their money out of their parity wallets anymore. So why would Pact have fixed these things? So Pact is Turing incomplete on purpose because we don't want recursion attacks. We don't want you stuck in an infinite loop burning up all your gas. And if you're trying to do something for which you would need recursion, like running Dijkstra's algorithm to find the shortest path between New York and LA, you don't do it on a blockchain. there's no point in doing that on a blockchain. What you need to do is you take it off chain and then you do your computation and then you put it back on the blockchain. So Pact recognizes this fact that Turing incompleteness on a blockchain is dumb. So because we are Turing incomplete and we stripped out a bunch of other stuff, we also have a full formal verification suite for Pact, which means that you can, in our annotated language, write in, like, prove that this field doesn't ever go below 0. And it will prove in the infinite space of possibilities of things that people could shove in there that it will never go below 0. And so Tarun talked about multiple kinds of safety. And this is the kind of safety where you know that what you're intending for your code to do is going to actually do. But just on the off chance that the code doesn't do what you want it to do, you can actually fix it, because in Pact smart contracts, there's abstraction between the address of the contract and the name, which means that you can rename your contract and say, like, version 2, whoops, that was a problem. Pact smart contracts are upgradable. And you can actually read Pact code. It's not like some sort of convoluted JavaScript. This is the hello world contract for Pact. It's 15 lines, and you can just read it. It makes sense. It tells you exactly what it's doing. You're defining some keys, you're defining some data, you're defining a function, and then it goes. If you tried to do this in Hyperledger, it's 150 lines to do this same thing, because you have to handle all these other abstractions underneath and define a whole bunch of calls, and Pact just deals with that stuff for you. So that's why I think Pact is cool. Moving forward, we have other things that I also think are cool. And so let's start. Private blockchains. People think that private blockchains maybe aren't cool because they're more into crypto stuff. But bear with me here. I think that actually, in the context of even people that want to do public applications, private blockchain can still be cool. So this is a world in which you have a walled garden, and only the people that you let in can see your stuff. And why would you use a blockchain instead of a database? You have non-mutable transactions. You're basically forcing people to use a type 2 database system. And you can't go back and change them because of this whole cryptographic hashing thing. You can't go back and change old records without totally screwing up the whole thing. Then, because you have to sign each transaction, you have strong attestation of who put what thing on the ledger. And then you can just simply replicate data very quickly. So you have the consortium model that everybody's like, oh, you know, this consortium of banks is going to share data between competitors. So there's that one. But then also, if you have a company that has nodes across multiple countries, then you can also have, you know, your Asia node and your US node and your Europe node, and they can very quickly replicate data across them without having to worry about disaster recovery. And then there's also, we're working on with another company for a tighter auditing chain where you can have third-party auditors submit data and you know who did what and when, and you can actually track that stuff down. So as part of a public application, private blockchains can be used to do interesting things in terms of taking things off-chain. So right now, where you have an oracle on a public blockchain where it goes who knows where, doing who knows what with what data, if you connect a private blockchain to the public blockchain with the Pact channel, you can actually prove that the information that happens on one side happens on the other, but you don't have to necessarily share it. So that's their whole hybrid blockchain. You can have public and private at the same time. So other private blockchains, some of them have unsafe development environments because they're on the EVM. It's not their fault. Some of them aren't really blockchains, like Corda. They're totally upfront about the fact that they're not a blockchain, but they use the word blockchain because it's sexy and it sells. Axoni, I mean, all these people are way more successful than we are in that they have bigger clients and more contracts, so I don't feel bad picking on them. Axoni doesn't have an open source smart contract language, although if you go to their website, it does say committed to open source, whatever that means. Or you can try to use Hyperledger Fabric, and it's not going to work past 8 nodes. If anybody's ever figured out how to make Fabric go past 8 nodes, call me, because I would love to figure out how you did it. So Scalable BFT integrates with the public blockchain Chainweb, provides Pact open source protection. So you can use Pact on top of scalable BFT. And then it has a true BFT consensus mechanism. It's not a database, it's actually BFT. And it scales up to, so far our sims can run on the old version of Pact. We haven't tested the new version of Pact yet. Up to 200 nodes, you're still getting 8,000 transactions a second. So if you want to try scalable BFT, it's on the AWS Marketplace, and you can go download it and try it for free. Last piece, I know I'm running out of time, but I'll keep talking fast. Chainweb. This is my favorite part. This is the part on which I work the most. So our proof of work technology for a public blockchain. Chainweb is a protocol that uses Nakamoto consensus, because 10 years later, it's still kicking despite everyone's attempts to hack it and take it down. And if we can figure out how to use proof of work and do it in an efficient way, in a way that scales, then it's worth trying to do. So Chainweb takes proof of work, and we have many different chains. All of them are running the same Nakamoto consensus, all running the same hashing algorithm, and they share data with each other, which gives us the ability to do high throughput while still getting to use proof of work. So we get higher throughput and higher security and greater decentralization without having to change the amount of energy that you're putting into the system. I give an hour-long talk just about this consensus mechanism. It's on the internet. I don't have time to do that whole thing today. If you want to learn more about it, go listen to that. But basically, each chain is an individual ledger that maintains its own state. And then if you want to transfer money from one chain to another one, you do it with simple payment verification. So all of the chains are equal. There's no hub. There's no main chain. They all have their own ledger and maintain their own state. They cross-reference each other by, if I finish a block on this chain and you finish a block on that chain, then we swap the proofs of the blocks we just finished and include them in the next block. Then miners mine the entire network, and users transfer money from chain to chain. And really, that's going to be totally abstracted away in when users interact with Chainweb on a casual basis. It's just going to be, I'm paying this person over there, and it handles having to transfer from chains, and it's not going to be a big deal. So the Chainweb really as a protocol can be applied to any braid size. It could be a potentially very large network if there's demand for such, but obviously bandwidth increases the more chains that you add, so we're going to wait to make it bigger until there's demand to do so. Oh, I missed a point. The graph structure of Chainweb is fixed, so that each time you want to change it, you have to hard fork to a different configuration. This is what allows us to get the most efficient way of transferring information across the network. You can have a fixed graph structure that has a maximal degree diameter solution so that you can propagate information efficiently. It's not an arbitrary DAG. Arbitrary DAGs have this potential to bottleneck. And you might hear arbitrary DAG projects say like, oh, we get 1 billion bajillion transactions per second. But that's with all nodes communicating equally across the network with even distribution, which in real life doesn't actually happen because people want an asset that's only traded on that. Or, this gets slow and everybody bottlenecks over there. And so fixed DAGs have this structure that can be maintained in a way that's safe and is not arbitrary. So this is a sample of a 20-chain braid of Chainweb. So for example, if you finish a block on chain 2, then it broadcasts to chains 1, 3, and 16. So what are we working on? We are launching Chainweb soon. Testnet happens the end of next month. Mainnet, I'm going to say this year. We have more optimistic deadlines, but I'm not going to say them in front of anybody else. Finish Pact. We're almost feature complete with everything that we want to put into Pact. We right now have verified interfaces, which is basically an ERC20 that checks itself to make sure that it was implemented correctly. and grow our developer community. We are doing that. We are trying to go out and get people excited about Pact as I am. Then launch our POCs and partnerships. So right now we're working on some of these private and hybrid private and public blockchain projects. We completed a pilot for a health insurance company that was working on sharing provider data. We are working with an insurance company for better auditing, talking to a construction company about supply chain, real estate tokenization projects, and we're also working on this project that I'm super excited about called Remedy that does vaccination tracking. And right now they're doing it overseas, but they want to come into the United States and do a health data tracking project on US soil, which means they're going to have to follow HIPAA. And basically that's something that you can only do with a blockchain technology that allows you to upgrade your smart contracts. And so they're using Pact, and they're going to use the hybrid smart scalable BFT and hopefully chain web system. And yeah, so that's what we've got going on. I went through a lot of stuff, and if you have questions, let's talk about it.